Hi guys. For the next question that I want to go over is this one about a helium blimp. So these blimps are pretty cool. The whole entire thing is filled with helium, and so they drive around with this huge tank of gas on their backs, basically. And so this helium blimp has 8.06 times 10 to the 28 helium atoms, right? Which sounds like a lot, but how much does the helium in this whole blimp actually weigh in kilograms? Okay, so we're going to go and kind of set this up. So here we've got our question again right at the top. It's written. And the first thing I'd like to do is write out a plan. And so I look at what information I have. And this one's pretty simple because it's only given us one set of information. And so the information I have is 8.06 times 10 to the 28 helium atoms. Okay, and the question that we want to answer is how much does that weigh in kilograms? And so how many kilograms of helium is that? Right, so I have to kind of think through this a little bit and figure out how to get from atoms to kilograms. And anytime I see kilograms, I automatically kind of think, okay, I probably need to go to grams of helium. Okay, and I know that 1,000 grams equals 1 kilogram of whatever substance I'm talking about. Okay, and so then the next step is, okay, when I see atoms, that's kind of another like clue that I can convert from atoms to moles of helium, and then do that using Avogadro's number. Okay, and then the last step is for moles to grams of helium. And since these are the same helium to helium, I can use the molar mass or the atomic mass on the periodic table for that helium. Okay, so now remember, I have my whole entire plan laid out. Remember, for every single arrow there is in my plan that I'm going to go through is one dimension of my dimensional analysis. And then every break right here is the unit and label that my plan should end in. Okay, so this is a 1, 2, 3-step calculation that will get me from helium atoms into kilograms of helium. Okay, so we're going to start this off, and hopefully I can fit this all into this one line right here. So we're going to start with 8.06 times 10 to the 28 helium atoms. Okay, and anytime I start, I usually start, almost all the time, I'm going to start with that number on the top. Okay, next I use Avogadro's number. Avogadro's number is 1 mole equals 6.022 times 10 to the 23 something, right? And in this case, it's going to be atoms. Since these are equal, I'm going to choose which one goes on the top and which one goes on the bottom. Since my atoms are on the top here, I need to put atoms on the bottom. So my moles go on the top, 1 mole, and the moles I'm talking about are helium. And Avogadro's number goes on the bottom here, 6.022 times 10 to the 23 atoms of helium. Okay, so that first arrow, that whole thing right there, becomes this dimension right there. Okay. And if I look, helium cancels with helium at the bottom. If I divide those out, it just becomes 1, so it cancels. And then atoms cancel with atoms. And I'm left with moles of helium here. And look, my plan has moles of helium there. So it actually matches moles of helium, moles of helium. The next step is I'm going to go to my periodic table and look up helium. When I look that up, I see that helium weighs 4.003 AMU of helium. Now remember that we can replace that AMU with grams per mole. So this number actually equals 4.003 grams of helium over 1 mole of helium. And because it's a ratio, I can use it either way with grams on the top or grams on the bottom, or vice versa. So when I go back to my equation, I should have written this lower, I'm sorry. But when I go back to this equation, I notice moles of helium are at the top. So I need to move moles of helium at the bottom. I'm going to draw this line out, and 1 mole of helium is going to equal 4.003 grams of helium. So moles of helium cancels with moles of helium. This dimension is from this arrow right here, right? And we're left with the unit of grams of helium, which is the same as this grams of helium right here. Okay, so every arrow is a dimension. Every spot in that dimension tells us what units we should be at. And then the very last step, we're going from grams to kilograms. And so because I've got grams of helium at the top here, I'm going to put grams of helium at the bottom. And that equals 1 kilogram of helium at the top. Okay, it's the last dimension. So after this, my problem's done. So grams cancel with grams, and helium cancels with helium. So when I go through, I multiply all of the numbers across and divide by all the numbers at the bottom. Notice that every single unit and label cancels out except for this end one right here, kilograms of helium. If you have units and labels that don't cancel out during the problem, they have to end up in your end equation, and maybe you've done something wrong. So the answer I get is 536 kilograms of helium. Okay, so I've got my unit, kilograms, I've got my label, helium. The last thing I want to check is number of significant figures. So in my initial measurement, I have 3 significant figures. And here I've got 4, but it's kind of a definition, so I'm not going to worry about it. Here, this is from the periodic table. There's 4. Again, it's a bigger number, so I'm not going to worry about it. This is a definition, so I'm not going to worry about it for significant figures. So my answer should have 3 significant figures. So every single time I calculate significant figures. I make sure I've got my unit and label. So the answer to this is 536 kilograms of helium in that big, huge blimp. So hopefully that helps. If you have any questions, feel free to comment. Let me know if you have any problems.